Imagine holding a piece of solid metal engineering right in the palm of your hand.
Oh, yeah, like a tiny metal brick.
Exactly. It's so dense, it feels like a miniature brick. I mean, it's barely larger than a standard 35 millimeter film canister, but, and this is the crazy part, this pocket-sized device from the 1940s captures an image roughly 30% larger than the professional full-frame digital sensors most people use today.
Which is just wild to think about.
Right. It totally flips our modern assumption that, as technology gets smaller, you have to sacrifice physical scale and output quality.
It's a really fascinating contradiction.
Yeah.
Because we're so conditioned to think of progress as this straight line toward miniaturization, usually at the cost of physical sensor size.
Yeah.
But mid-century mechanical photography, it just throws that entire narrative right out the window.
Which brings us to the core of our deep dive today. We're tracing the historical evolution of a camera that essentially shouldn't even exist by today's logic. We're talking about the Kodak Bantam series.
A true classic.
Specifically, we're putting a massive spotlight on the 1947 Kodak Flash Bantam. We're going to look at how a corporate push to eliminate wasted space accidentally created this incredibly durable, high-performing mechanical tank.
And perhaps more importantly, how a fiercely dedicated community of modern analog hackers are keeping these things alive.
Yeah, using liquid rubber, pitch black rooms, and some serious DIY ingenuity to shoot with these vintage marvels today.
To really grasp why the Flash Bantam is such a mechanical triumph, we have to, step back into the mid-1930s.
Okay, set the scene for us.
So Kodak was dominating the market, right?
Yeah.
But their engineers were looking critically at the industry standard 135 format.
Which is what we all know as standard 35 millimeter film.
Exactly. And they realized that a massive percentage of the physical film strip was just dead space.
Because of the sprocket holes.
Precisely. The mechanical perforations running down both edges of a 135 film strip, they're necessary for the internal gears of a standard camera to grip and advance the film.
Right, to pull it to the next frame.
Yeah, but from an optical perspective, they are purely wasted real estate. You can't put an image there. So Kodak's solution was, well, it was elegant in its simplicity.
What did they do?
They took the exact same 35 millimeter wide film stock, but they completely stripped away the perforations.
There are no holes at all.
None. They called this new unperforated format 828.
It's basically the visual equivalent of taking a film with heavy cinematic letterboxing, those black bars, and just peeling them away to reveal this massive IMAX picture hiding underneath.
That's a great way to put it.
You are using the exact same screen, but suddenly the image is monumental.
And the math backs up that analogy too. By utilizing the film edge to edge, the 828 format yielded a 28 by 40 millimeter negative.
Wow.
Yeah, compare that to the standard 24 by 36 millimeter frame of standard 135 film.
That's a huge difference.
It really is. That extra 30% meant mid-century photographers could get significantly larger, crisper enlargements without the grain falling apart.
Which was a big deal back then.
Huge. But, a new film format needs a delivery mechanism. Kodak had to convince the public to actually adopt 828, so they launched the Bantam line as this premium showcase.
Right, they needed a flagship, something that would make people stop and stare.
And they delivered that in 1936 with the Kodak Bantam Special. They actually brought in Walter Dorwin Teague to design it.
Oh, wow. Teague is an absolute legend in industrial design.
He really is.
Anyone familiar with the aesthetic of the 1930s knows his work. I mean, the classic Texaco service stations, the branding for TWA, early Polaroid concepts. He was basically the pioneer of the streamlined modern aesthetic.
And he applied that exact philosophy to the Bantam Special. It wasn't just a tool, it was a luxury artifact.
It looks incredible in the photos.
It does. Teague designed this cast aluminum shelf finished in high-gloss black enamel, wrapped in these sweeping, machined Art Deco metal curves. It literally looked like a miniature locomotive.
So cool.
It was marketed to high society consumers and was priced accordingly. Today, it's basically a museum piece.
I think our sources actually mentioned it's a featured item in the Paris Camera Museum.
Yeah, exactly. It is exceedingly rare to find one in the wild.
But a luxury museum piece doesn't change the way a whole generation takes photos. The Bantam Special proved the format worked, but the real cultural shift happens after World War II.
Right.
Kodak realizes they have this incredibly powerful, pocketable format, and they need to strip away the Art Deco luxury to create a robust, everyday tool for the post-war American family.
And that is the genesis of the 1947 Kodak Flash Bantam. They took the large negative capability of 828, and housed it in this highly practical, nearly indestructible package.
A real tank.
This is where the mechanical engineering really shines. The Flash Bantam utilizes a strut folding design.
Which I have to say is incredibly satisfying to use. It's not like a fixed lens point and shoot. When it's collapsed, it's just a smooth metal block.
Totally flat.
But you press the small knurled button near the winder, and the entire front lens board just violently springs outward, locking into place.
The word violently is accurate. The tension on those internal springs is remarkable.
It's aggressive.
It is. Even on models that have been sitting in a closet for 75 years, that lens board snaps into the picture-taking position with absolute authority.
And it has to, right?
Yeah, the design of those metal struts is critical. They don't just hold the lens, they lock it into perfect parallel alignment with the film plane. Without that rigid parallel precision, your image would suffer severe focal plane distortion.
So once that lens pops out, you obviously have to frame the shot. And this camera utilizes something called a flip-up reverse Galilean scale focus viewfinder.
Quite the mouthful.
It sounds like an instrument from a nuclear submarine.
Yeah.
But mechanically, it's just two metal frames on the top plate that you manually flip up and sight through.
Yeah, it's purely optical framing. But the glass you were actually framing for is where Kodak invested heavily. The Flash Bantam is equipped with a Kodak Anistar 48mm f4.5 lens.
A very specific lens.
And the critical upgrade for this post-war model was the application of aluminized hard coating to all the air glass surfaces.
Let's dig into that for a second, because lens coatings are something we completely take for granted today on our phones. Why was aluminized coating such a massive selling point in 1947?
Well, it comes down to the physics of light transmission. Whenever light hits a bare, uncoated pane of glass like an early camera lens element, a significant percentage of that light doesn't actually pass through.
It bounces off.
Exactly, it bounces off the surface. Inside a complex lens with multiple glass elements, that light bounces around internally. It creates flare, washes out the deep shadows, and just severely degrades contrast.
Oh, I see.
So aluminized coating is this anti-reflective layer that fundamentally changes the refractive index at the glass surface. It forces the light to pass right through rather than reflect.
Meaning much sharper contrast, which I imagine would be especially crucial considering this was the era when color film, like Kodachrome, was really becoming a consumer reality. Washed out contrast would just ruin those early color dyes.
It's exactly the issue. The coating ensured color purity. Now, while the optics were top tier, the operation of the camera remained strictly manual.
Right.
You had an aperture dial, leaf shutter speeds ranging from 125th to 1200th of a second, plus bulb and time settings for long exposures.
But the defining characteristic of this era of consumer photography is that the focus is completely manual scale focus, right?
Yes. You turn the lens barrel to an estimated distance from 2.5 feet all the way to infinity.
And here is where I kind of struggle with the post-war marketing strategy. If there is no built-in rangefinder to help you triangulate the distance, how is this pitched to casual consumers?
It seems risky, yeah.
I mean, the average dad at a 1947 family picnic isn't a human tape measure. Wouldn't they end up with rolls of totally soft, out-of-focus vacation photos?
Well, that assumes they were shooting wide open at f4.5 where the focal plane is razor thin.
Ah, okay.
But the mid-century approach to photography was heavily reliant on depth of field. Film speeds were slow, yes, but outdoors, users were instructed to stop the lens down to f8 or f11.
And that fixes the focus issue.
Largely, yes. At those apertures, the Anistar lens provided an incredibly forgiving depth of field. If you estimated your subject was, say, 15 feet away, but they were actually 20 feet away, the optical depth at f11 meant the entire zone from 10 to 30 feet was acceptably sharp anyway.
Oh, wow.
It's the classic F8 and be there photojournalism philosophy, just applied to family snapshots.
That makes a lot of sense. And for those who demanded precision, the sources note Kodak offered a modular workaround. You could purchase the Kodak Service Rangefinder as an add-on accessory, slip it onto the camera, and use it to calculate exact distances before dialing it into the lens.
A brilliant way to upsell accessories while keeping the base camera compact.
Very smart.
The other major evolution, and the reason flash is literally in the name, was the integration of a flash sync post right behind the lens board.
Which changes the entire dynamic of when and where you can take a photo. You attach a Kodak flash holder, plug in a single-use photo flash lamp like the SM or number 5 bulb, and the camera handles the rest.
Yeah, the internal mechanics there are beautifully timed. The shutter release doesn't just open the lens, it simultaneously closes an electrical circuit, triggering the explosive magnesium flash of the bulb to peak at the exact millisecond the shutter blades are fully open.
That is so cool.
Suddenly, the Bantam wasn't just a daytime outdoor camera. It was capturing birthday parties indoors, night scenes, low-light events.
So we have this pocket-sized, heavy metal, brilliantly engineered device that fundamentally outperforms standard 35mm formats. And honestly, the most shocking detail from our research is the modern valuation of these things.
Oh yeah, the pricing is wild.
Because millions of these were produced, they are deeply undervalued in the current vintage market. You can literally find a functioning Flash Bantam at a flea market for $10. Online, they frequently hover around the $50 to $60 mark.
They are arguably the lowest barrier to entry for medium format style negatives today. The cast metal bodies survive the decades flawlessly. The shutters usually just need a tiny bit of exercise to clear out old lubricants. But there is one universal, unavoidable physical failure point when dealing with a vintage folder.
The bellows.
Yes, the bellows.
Age and friction are just brutal on those corner pleats. I mean, you're taking 80-year-old fabric and paper and folding it in and out hundreds of times.
The material inevitably dries out and cracks. In severe cases, large tears create massive, obvious streaks of light across your film.
Which completely ruins a shot.
But the insidious issue with vintage bellows is the microscopic pinholes. You often can't even see them with the naked eye. They let in an ambient trickle of light that scatters across the film plane.
And that creates that milky, low-contrast haze over the entire image.
Exactly. Many people assume their lens is filled with fungus, but they are actually just dealing with ambient light leaks.
And you can't exactly pull up a modern supplier and order a fresh set of custom bellows for a 1947 Bantam.
No, you definitely cannot. But this is where the modern analog community steps in with some incredible DIY ingenuity. The standard repair hack is an absolute masterclass in lateral thinking.
I love this part.
So you take the camera into a windowless pitch-black room, you open the film door, place a small high-intensity LED flashlight inside the camera facing the lens, and close the back.
It's the bicycle tire method.
Right.
But instead of submerging a tire in water to look for escaping air bubbles, you submerge the camera in darkness to look for escaping light.
Exactly the principle. As your eyes adjust to the dark, those microscopic pinholes light up like a starry night sky on the outside of the bellows.
That's amazing.
Once you identify a leak, the repair process is incredibly clever. You take a thin safety pin and gently pierce it through that specific illuminated hole from the outside in.
Leaving the pin embedded in the fabric.
Yes, basically as a marker.
Yeah.
Then you open the camera back, remove the flashlight, and look inside. You can see the sharp tip of the pin protruding through the interior wall.
Okay, I'm with you.
Then you take liquid electrical tape, which is this highly viscous, vulcanizing liquid rubber, and you apply a tiny dab directly onto the tip of the pin inside the camera.
And when you pull the pin out from the exterior,
The withdrawal motion drags that liquid rubber directly into the microscopic cavity. It fills the void completely.
that is genius.
And as it cures, it remains utterly flexible so the camera can still fold flat without snapping the patch. Best of all, because the rubber is pulled from the inside, the exterior aesthetic of the camera remains totally pristine. You preserve the vintage look while perfectly sealing the light leak.
It's a brilliant rebellion against the idea that aging tech is disposable.
Absolutely.
But let's address the massive looming roadblock for anyone who actually attempts this. You fix the bellows, you polish the luminized lens, you have a fully functional 1947 Flash Bantam. The problem is Kodak discontinued the 828 film format half a century ago.
Yeah, that's a slight issue.
You cannot just walk into a store and buy a roll of unperforated 808.
The camera is hungry, and the food source is extinct. But analog photographers are nothing if not stubborn. Today, there are two distinct paths to feeding a Bantam.
What's the first one?
The straightforward route relies on specialty cottage industries. Suppliers like Film for Classics, custom-cut modern film stocks like Kodak Ektar 100 or Portra down to 828 dimensions, roll it with backing paper, and distribute it through specialty retailers like Central Camera in Chicago.
Okay, so it's a lifeline, but it's expensive, and supply is often highly intermittent.
Very intermittent.
Which leads us to the second path. The hardcore underground method of respooling the film yourself.
Oh man, if you want to shoot whatever black and white or experimental stock you desire, you have to build the rolls from scratch.
Sure.
This requires a level of dedication that borders on the obsessive.
I can imagine.
First, you must possess original 828 metal spools. Because the format is dead, these spools are irreplaceable artifacts.
Right.
You also need an original, intact strip of 828 paper backing, which shielded the film from light.
Assuming you actually have those relics, the process sounds like performing surgery in a cave. You have to work in absolute pitch black darkness or inside a light-tight changing bag.
Yep.
You take a bulk roll of standard 35mm film and you blindly cut a strip exactly 14.5 inches long.
That precise measurement accommodates the 8 frames the Bantam expects.
Hmm.
But the environment is critical here. Our sources emphasize running a humidifier in your darkroom before you begin,
A humidifier. Why?
because the physical act of unrolling film generates static electricity. In a dry room, that static acts like a magnet for atmospheric dust, pulling microscopic particles directly onto the emulsion.
Oh, no.
Yeah, if you seal that dust into your roll, your negatives will be covered in sharp black artifacts.
Okay, so in a humid, pitch black room, you find the exact starting mark on the vintage paper backing by touch.
By touch alone.
You tape your freshly cut 35mm strip to the paper, and you wind the entire assembly backwards onto the antique metal spool, keeping the tension flawlessly tight so light can't leak through the edges.
It takes practice. Now, using modern 35mm film introduces a fascinating mechanical conflict. Remember, 828 was unperforated. Modern 135 film is riddled with sprocket holes.
Right.
Because the Bantam's internal mask is designed for that massive 28 by 40mm exposure, the image projected by the lens will actually expose entirely over the sprocket holes of the modern film.
Which is where a mechanical compromise becomes a massive artistic advantage.
Oh, totally.
That sprocket hole aesthetic is incredibly sought after right now. Groups like the Tokyo Camera Club have massively popularized this gritty, tactile look. The image bleeds right off the edge, integrating the mechanical perforations into the art itself.
Looks so cool.
It visually proves that the image was captured on analog machinery, which is highly appealing in an era dominated by perfectly polished, AI-generated digital gloss.
It's a beautiful aesthetic, but the camera's internal mechanics will fight you.
How so?
The Flash Bantam features an automatic frame spacing pin. It's a tiny physical probe that drags along the film as you turn the winder. It was designed to drop into a single, specific alignment hole on original 828 film, locking the winder perfectly at the next frame.
Oh, wait, but if you feed it modern film, that pin is dragging across dozens of sprocket holes?
Precisely. It will plunge into the very first sprocket hole it encounters, instantly locking the camera before you've advanced even a fraction of a frame.
That sounds infuriating.
To bypass this, the operator has to actively hack the winding process. You must manually depress the film release button on the back of the camera, holding that internal pin out of the way while you wind.
You are essentially overriding the camera's autopilot.
And because the lock is bypassed, you have to rely entirely on the ruby or green safety window on the back door.
To see the numbers.
Yeah. You watch the numbers printed on your vintage backing paper slide past the window, stopping the winder manually when the number 2 appears, then 3, and so on. It demands your complete attention.
Which makes the final step of this journey incredibly nerve-wracking. You've successfully hacked the camera. You've shot your 8 beautiful sprocket-exposed frames, but now you have to get the film developed.
The scariest part.
Most modern photo labs are built around automated machinery designed for disposable metal 135 canisters. The technicians pop the canister, run the film, and throw the empty metal shell right in the garbage.
And if a lab does that to your 828 roll, your camera essentially becomes a paperweight.
Yeah.
Those metal spools and that specific length of backing paper are your capital. Lose them, and you can never respool again.
One of the guides in our research explicitly states that before handing an 828 roll over to a commercial lab, you must extract a pledge of their firstborn from the technician.
Seriously.
It sounds hyperbolic, but the stakes are genuinely that high.
It requires a serious conversation with the lab. The film must be hand-processed in a darkroom tank, which means it will often cost as much as developing a 36 exposure roll despite only having 8 frames. The technician needs to manually unspool the film, carefully set aside the paper backing without tearing it, and return the metal spools to you with your negatives.
It is a labor of intense mechanical love from start to finish. And looking at the entire arc of the Flash Bantam, it's a brilliant reflection of mid-century industrial priorities.
It really is.
Kodak identified the inefficiency of sprocket holes and engineered a format to maximize visual yield. They wrapped it in this indestructible, pocketable strut-folding tank. And long after the corporate entity abandoned the format, a community of makers refused to let the hardware die.
Slicing film in humid dark rooms, vulcanizing microscopic bellows leaks, and wrestling with photo labs just to hear that mechanical shutter fire one more time.
Exactly.
It stands as a profound testament to the enduring value of repairable mechanical design. Consider the fundamental difference between the Bantam and the technology we rely on today.
They couldn't be more different.
The camera was built with the assumption that the user could understand its mechanics. If something breaks, you can open the door, observe the gears, identify the failure point, and apply human ingenuity to keep it functioning.
The machine doesn't hide its logic from you.
Contrast that with the incredibly powerful smartphone or a digital camera sitting on your desk right now. They are undeniable miracles of computation, but they are fundamentally black boxes.
Yeah.
They are sealed behind industrial adhesive, powered by degrading, non-removable batteries, running proprietary code, and deeply reliant on remote servers to process their images.
If the server goes down or the software update bricks the hardware, there is no amount of liquid tape that can save it.
Which leaves us with a critical question to consider about the artifacts we are leaving behind.
Yeah.
80 years from now, will an enthusiast be able to sit in their bedroom and hack a 2026 smartphone back to life to capture a memory?
Probably not.
Or have we permanently traded the beautiful, resilient permanence of mechanical engineering for the fleeting, disposable convenience of the digital age?
That is something that will definitely stick with me. The next time you capture a moment with a piece of sealed glass and silicone, take a second to appreciate the mechanical legacy of cameras like the Flash Bantam, still snapping away in the dark.